Let us look at question number 41 now. Silicones can be prepared by polymerization of CH3 whole twice SiOH whole twice. The chain length of silicones can be controlled by the addition of. So students, if you look at the options, the first option is R4Si. This is not going to take part in polymerization. If you look at the second option, R3SiCl, students, this is a chain terminating agent. So it is going to terminate the chain. If you look at the next option now, it is the chain propagation agent. It will just lengthen the chain in 2 dimension. So this is used for 2-dimensional chain propagation. If you look at the fourth option, RSiCl3, it is going to cause branching inside the polymer. So the examiner is interested in knowing the agent which can control the chain length. So obviously he is interested in the chain terminating agent, which is the R3SiCl. So which is given in the second option. So students, the correct answer to question number 41 is option 2. Let us look at the next question. Question 42. Thin layer chromatography is an example of adsorption chromatography, which involves separation of a substance of a mixture over a thin layer. In an experiment, it is found that distance moved by the substance from baseline is 4 cm, while distance moved by the solvent from the baseline is 10 cm. So the examiner is interested in knowing the retardation factor of the substance. If we talk about the retardation factor, which is represented by Rf, we can say that it is equal to the distance moved by the substance upon the distance moved by the solvent. So it is a very simple question. You just have to put the data. So distance moved by the substance is given to us. It is equal to 4 cm, whereas the distance moved by the solvent is equal to 10 centimeters. So this is equal to 0.4. Students, the answer which we are looking for in this question is option 2. Let us look at the next question now. Question 43. Consider the following statements. So in the first statement it says, during removal of temporary hardness by boiling, magnesium bicarbonate and calcium bicarbonate are respectively converted into MgOH whole twice and CaCO3. This is correct, students. If we talk about the heating of MgHCO3 whole twice, on heating it forms MgOH whole twice. Whereas if we talk about calcium bicarbonate, it gives us calcium carbonate plus CO2 plus H2. In this case also we have the liberation of CO2. So students, if you look at the second statement now, synthetic resin method is more efficient than the zeolite method. This statement is correct, students. If you look at the third statement now, H2O2 is immiscible with water. Students, this statement is incorrect. H2O2 is miscible with water in all proportions. So statement 3 is incorrect. So if you look at the fourth statement now, 30% weight by weight solution of H2O2 is labeled as 100 volume approx. Students, this statement is also correct. A 30% weight by weight solution of H2O2 is labeled as 100 volumes. Let us look at statement 5 now. In the presence of metal surface, decomposition of H2O2 is catalyzed. So students, this statement is correct. So it is because of this reason that H2O2 is stored in glass vessels or vessels made with wax linings, and it is also stored in the dark. So the examiner is interested in knowing the number of correct statements. Students, we can see that 4 of these statements are correct and we have to select option 4 as the correct answer to our question. Let's look at the next question now. Question 44. An organic compound is fused with sodium metal and the sodium fusion extract is obtained. The sodium fusion extract is boiled with iron 2 sulfate and then acidified with concentrated sulfuric acid. Then a blue colored compound is formed. Select the correct statement on the basis of the above information. The blue colored compound is FeNH3 whole 6 twice. Students, this statement is incorrect. The test is of nitrogen, but the nitrogen is converted into cyanide ions and not ammonia as mentioned to us in the option. If you look at the second option now, blue colored compound confirm that compound contains sulfur and complex is octahedral. Students, the test for sulfur is not carried out by using iron 2 sulfate. It is either done by reacting lead acetate or by the addition of sodium nitroprusside into the solution. So if you look at statement 3 now, blue colored compound confirm that compound contain nitrogen and in complex the primary valency of the metal is 2. So students, we know that the nitrogen is converted into cyanide ions with the carbon and the Fe plus 2 which is present It complexes with the cyanide ion which is present in the solution to form ferrocyanide ions, FeCN6, 4 negative. And some of these Fe2 plus ions are also converted into Fe3 plus ions by concentrated H2SO4, which is also part of the test. Now, this Fe3 plus ion and FeCN6 whole 4 negative, these combine to give us Prussian blue, which is the blue colored compound obtained. So it has a formula of Fe4, FeCN6 whole thrice. And if we talk about the oxidation state of the Fe involved, so the Fe outside the coordination sphere has +3, whereas the Fe inside the coordination sphere has a oxidation state of +2. So the examiner says that the blue colored compound confirmed that the compound contained nitrogen. This is correct. And in complex ion, the primary valency of metal is 2. So the examiner is interested in the oxidation state of Fe, which is inside the coordination sphere, and it is indeed equal to 2. So students, statement 3 is correct. If you look at statement 4 now, blue colored compound is FeSCN whole thrice. This is a blood red colored compound. It is not blue in color. It forms a blood red coloration. So if you look at the options now, we have to select the correct statement and we have to mark option 3 as the correct answer to this question. Let us look at the next question now. Question 45. Consider the following organic molecules. So we have been given 4 different carbocations. And the examiner seems to be interested in talking about the stability of these carbocations. Students, we know that carbocations are majorly stabilized by +M, +H and then by +I. So if you look at the electron donating groups which are attached, so we have a CH3 attached at the para position in option A and we have a CD3 attached at the para position in option D. So students, we know that the +H or the +R effect is only felt at the ortho or the para positions, while the effect is not felt at the meta position. So if you look at options A and D, in that case the carbocation will feel the +H directly because it is present at the para position, whereas in options B and C it will not. If we have to compare between A and D, so in A we have CH3 and in D we have CD3. So we know that the CH bond is easier to break than a CD bond, which means that a CH3 group will exert a greater hyperconjugation as opposed to CD3, in which the CD bond is difficult to break. So if we talk about A and D, A is going to be more stable because the CH bond can be easily broken. So A will be more stable than D. Now if we compare between B and C, so in structure B we have CH3 and in structure C we have CD3. So students, now we have to take into account the +I into picture. So if we compare the +I of H and D, definitely the +I of D will be greater than H. So this will exert a better electron donating effect as compared to CH3, however little it may be. So the structure given in option C shall be more stable than option B. So this is the order of stability of the given carbocations. If you look at the options, in the first option it says B is more stable than A. It is incorrect. In statement 2, it says B is more stable than C. B is the least stable of them all. This statement is also incorrect. If you look at statement 3 now, A is more stable than D. This is correct. And if you look at option C now, that C is more stable than A, students, this option is also incorrect. So we have to mark option 3 as the correct answer to question number 45. Let us look at the next question.